Okay, so this is the check your understanding for topic 8.11 and through 8.12, which is volume using the washer method. So let's see how we do. So we're going to let M be the region bounded by, oops, that's not what I meant to do. X squared, the y-axis, and the line y equals 8. Excuse me, y equals 9. Find the volume of the solid revolution created when rotating M around the x-axis. Okay. We've got y equals x, the y-axis, and the line y equals 9. And we're going to rotate it around the x-axis. So notice that there will be a gap here in the middle. When I spin this, imagine a rounded shape on the outside, kind of like be a circle on the outside, kind of like so, with a missing inside, like a. But anyway, there's definitely a big R and a little r. So in keeping, we're going to use big R is going to be this. This is going to be R is equal to y equals 9. So R is 9. Little r will be x squared. All right. So with that in mind, here we go. The integral will be from, if that's 9, that means this is 3. So from 0 to 3, pi goes on the outside. So from x to x, 0 to 3. Pi goes on the outside. Big R squared minus little r squared dx. Like so. Just clean this up a little bit. You get pi, the integral from 0 to 3 of 81 minus x to the 4th dx. So that's 81x minus x to the 5th divided by 5, divided from 0 to 3, pi, pi, 81 times 3, minus 3 to the 5th divided by 5, minus 81 times 0, minus 0 to the 5th divided by 5, this is going to be 0. So we end up with pi times 243, so 81 to the 3rd, 3 to the 5th is also 243, divided by 5. And so I'm just going to leave it there. Maybe I'll write just for grins and giggles. There you go. Good enough. Okay. Let's try again. Let G be the region bounded by this line and that curve. Find the volume of the solid when it's rotated around the y-axis. So let's go ahead and draw it. X plus 2x plus 2 is going to be this line right like that. X squared plus 2 is going to come like this, and then they're going to meet. So we're going to end up with that. So they're equal. X squared minus 2x equals 0 and x minus 2. So x equals 0 or x equals 2. Okay, not really enough room here. So I am going to find a blank back of paper. Of course, I don't have such a thing. This one. So just continuing here. I'm generally rotating around the y-axis though, so that changes things a little bit. X is 2. So when I plug in 2, I get 6. Because 4 plus 2 and 2 times, yeah, so I get 6. So, so that's 0, 2 and 2, 6. Those are the ordered pairs here and there. Okay. So my integral will be from 0, so the y values, because I'm rotating around the y-axis, that means it's going to be dy. So I need y values from 2 to 6. And so little r and big R. So big R is this one, but I need to solve it for y. So, and for x. Now we need the principal square root. So that's big R. Minus so then my little r is going to be the inside, and it will just be f y minus 1 squared by. There's my interval. So setting it up is the hardest part by a lot. Sometimes you have to manipulate the formulas. Usually the integration is not so bad. Setting it up is awful. We're going to let the calculator handle this for us. We don't need to, but we're going to do it anyway because I don't want to do it by hand. So pi, math 9, integral from 2 to 6, parentheses, second square root, oops, parentheses, square root of x plus 2? Yeah. Whoops, I wrote that wrong. Like, that doesn't make any sense. Okay. X minus 2. Okay. Then close the parentheses squared minus 0.5 for 1/2. Actually, parentheses. X minus 1, close parentheses, squared, dx. And if I wanted to do that again, without the pi in it, 2 2/3. So that's pi times 2 2/3, which is, what's actually frac that. Force it to be a fraction 8/3. That's better. Which is 8 pi-thirds is my volume. In case you know you're dealing with multiple choice, and you can develop it that way. There you go. So again, setting it up is the hardest part. Do your best there. All right, last question. Let R be the region bounded by the curves f of x equals x cubed and g equals sine of pi x. So this one is g, and this one is f. Okay. Find the volume when I rotate this around the x-axis. So there's little r, and here is big R. Not to be confused with this R. So we're going to use R1 and R2. Just because of the big R there. All right. So pi, because I'm rotating, outer radius, which is g, make that green, which is why I identified right away. Little r, which is f. I should really use orange for g. Maybe even orange for that. All the stuff that doesn't matter. Like what color I'm using. Especially since I'm fine now. Okay. When it comes to these, I really, really want a calculator to evaluate them. I can do them by hand, but squaring some of these functions is annoying. You got some chain rule issues, all of that stuff, especially this. I don't know what sine squared of pi x, what the antiderivative is, so that's where my calculator is going to come in handy. So I am going to go ahead and go y equals, we're going to put g of x here first, which is sine of pi x, close parentheses, and the other one is 8 cubed. Okay, so then we quit. And we have, oh wait, from where to where? I didn't do that part. So, since it's 1/2, but I'm going around the x, so that's what I need to know. It's not actually 1. The integral is from 0 to 1/2. Almost forgot that until I went to try to put it in here. Math 9. I'll put pi in later. And so I put g as the first equation because it was first on my problem. So I'm going to have alpha trace for the menu, and I'm going to put y1, and I'm going to square y1 minus alpha trace for that menu, y2, also squaring it, dx. Mess looks ugly, 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 and it should. If I try to force it to be a fraction, oh, it does come out really nice. Let's check it. I'm looking at that going, oh no, it's terrible. Not so bad. So that equals 5 over 28 pi, which is approximately equal to 0.5606 units cubed. There you go. That's it. All there is to it. It's a little tricky though. So even though I said, oh, that's all there is to it, it's not complicated. Good luck.